Alright, so let's start with 28 and 29, where we need to use these tables to figure out how many triangles that we actually have. So even though on 29 we're given angle C and B, this works with, they just used A, so it's the angle A and the side that's opposite. So we have C and the side that's opposite, so that's going to be like our A. So instead of A, we're just going to compare that with C. Okay? The letters are arbitrary, so you want to use them to fit the information that's given. So I'm just going to draw a generic triangle, A, so you can see that it is side-side angle. So angle C is 34. Side C is 24, and side B is 29. So we would have side-side angle, okay? So we need to do a comparison. We know that H equals B sine A, but remember, we're not using A, we're using C. So our H is equal to B sine of C. So H equals B is 29. The sine of C is 34, and we'll calculate that. So 29 sine 34 is 16.2. Alright, so we want to compare. So H is 16.2. A, we're not worrying about. We're going to compare that to C, which is also A, I'll say. C is 24, and B is 29. So we have to look at our chart to figure out which one occurs. So let's look at the first one. Is C smaller than H? So here's C, 24. H is 16. Nope, that does not work. Alright, is C equal to H? Nope. Alright, is C, 24. Is 24 smaller than B? 24 is smaller than 29. Is 29... I'm sorry, bigger. Is C bigger than B? So C is 24, B is 29. No, C is not bigger. Alright, let's do our next one. C is 24, so is 24 bigger than, oops, B is 29. Is 29 bigger than 24? Is bigger than H is 16? Yes, that's true. Let's just keep going to make sure. So, and we don't have the obtuse angles, so we can't do those. All right, so that's how we know there's going to be two triangles. All right, so I'm just going to make a little note, two triangles. So I'm going to erase this so I have some room. And then we'll find the two triangles. So I don't do anything with the drawing. I just use the numbers and compare it to the chart with all the rules. Alright, so let's find them. So two triangles. Okay, so let's find, we can do law of sines. Oops. Okay, so law of sines says we have the side and the angle across from it. So I'm going to do 24 over the sine of 34. And, which means we're going to have one obtuse and one acute angle. What's our other side? 29 over sine of B. So we'll cross multiply. Divide by 24 to get sine alone. And since we're looking for the angle, we're going to find the inverse of sine. So inverse sine, 29 sine of 34 divided by 24. So B equals 42.5 on our first triangle. And then you can continue Let's keep going. I'll do 1. So 180 for the angles minus 42.5 minus 34 gives you 103.5. And then continue with law of sines to find the third side, okay? 24 over sine of 34 equals, we don't know A, over the sine of 103.5. Cross multiply, divide, so 24 sine of 103.5 divided by the sine of 34. Oops, I hit the wrong button. Let me try that again. 24 sine 103.5 divided by the sine of 34. Alright, so that side is 41.7. Okay, so now we have to find the other triangle. I'll just do it here, and we'll do this problem somewhere else. Alright, so now we still know, let's just make this A, B, C. I'm still at number 29 though. We have to know this one stays 24, this stays 29, and then this angle is 34. Alright, so we've got since from trig, this one's a little harder, the sine of 103, so remember this is 180, this is 0, so 103.5 would be about right there. Alright, so let me change colors. And since we are originally given C and B, we want to go off the B angle. So since we knew it's sine is positive in the first quadrant and sine is positive in the second quadrant. So if we have 42.5, we want to take that off of 180, and that will give us our other angle for B. So 180 minus 42.5 gives you, B can now also be 137.5, because if you take the sine of 42.5 and the sine of 137.5, you get the same answer. So there's two angles that give you the same answer. That's why there's two triangles also. So then you need to continue like you did on the first triangle. Find A by subtracting from 180, and then we need to use law of sines to find the side. Alright, let's move this one. Let's move this one down since I don't have any room. Alright. I know this is a long video. This was a long section, so same thing. I'm going to draw my triangle. Sorry, I can't draw straight. I'm using a tablet. I don't have a touch screen. A, B, C. Angle B is 142. Angle A is 18. And C is 10. Alright, so we are not given side-side angle. So we can find the other angle. So 180 minus 142 minus 18 gives you 20. Since we're not given side-side angle, we're going to have one triangle, and I need to use law of sines. 10 over sine of 20. Let's just find a. So a over sine of 18, cross multiply, and divide. So a equals 9.03, and continue to find the other side. Do law of sines again. All right, let's move up to normal distribution. So they tell you that it's distributed normally. You can make a graph. So in the middle is the mean, which means that this much is 50%. That's always good to know. And then the bottom half is also 50%. We're going to label 3 standard deviations above and 3 below. You put the mean in the middle. And then each standard interval is 9 apart. So when you go forward, you add. When you go backwards, you subtract. So 54 plus 9 plus 9. Go backwards, we'll subtract. From the video, you are supposed to memorize that the percents will always be 34 right here, 13.5, 2.35, and then if you add all of these up, it adds up to 99.7, which means you're left with 0.3. Divide that by 2, and you're left with 0.15. So, all right. So then these numbers will correspond, and you'll just add up what they want. Let's look. All right, from 27 to 72. So here's 27 to 72 goes right here. So you're just going to add up all those percents. So I'll just write it here once. 13.5 plus 34, 34, 13.5, and then our last one is 2.35. So 97.35%. Less than 54, so here's 54, and we want everything that's less than that. Well, half of that is 50, so 50 plus 34. 84%. Greater than 36. Same thing, that top is 50, so 50 plus 34. And then the last one from 54 to 72. So we're going to take 13.5 plus 2.35. These percents never change, so you'll just keep using them for every normal distribution problem. Number 13 and 14 are different. If you got 500 people and they want you to predict, you're going to take the number of people and you multiply it by your decimal percent. So I've got 500 people, and then I need to figure out what percent is between 36 and 63. So here's 36 to 63. So we've got 34 plus 13.5, which is 81.5%. We change that to a decimal, move it 2 to the left, or divide by 100, so times 0.815. Which is 407.5 people. Number 14, one person is using the internet for 120 minutes. Would this be considered an outlier? So an outlier is a number that rarely occurs. It's much larger or smaller than all the other numbers, which is when the majority of the percents occur. So 120 would be all the way up here, which is in the 0.15% chance occurring. So yeah, that's pretty rare. So yes, 120 lies in the less than 1% occurrence. So that makes it an outlier.